Welcome to the deep dive. We're super thrilled you are joining us today to unpack all of this.
Survey considerations. Oh, this is a fun one.
Question is, why does a specific tide gauge hundreds of miles away dictate how deep a submarine calculates it is in the middle of the ocean?
Because establishing a fixed z-coordinate depth in the ocean is arguably harder than establishing the x and y coordinates.
Because the water moves.
Right, the ocean surface is not a flat plane. It is a continuously shifting, undulating surface driven by lunar gravity, barometric pressure, and wind.
So if you measure depth relative to the water surface at 10 a.m. and measure the exact same piece of seabed at 4 p.m., your depths will differ by meters simply because the tide went out.
Precisely. So you have to mathematically subtract the tide from your raw measurements to figure out the true depth of the seabed.
Okay, so what does this all mean?
You have to reduce the soundings to a fixed theoretical plane called a vertical datum, using the predicted tide tables for a Victoria.
Which is likely because it is the closest major port to the survey area. That seems logically sound for a localized offshore operation, doesn't it?
It does, but looking at the macro-level engineering. The Imbituba tide gauge, located in southern Brazil, is the official reference point for the entire Brazilian geodetic system.
Ah, so it defines the geopotential surface for the whole country's infrastructure.
Yes.
Building a pipeline that stretches from the deep ocean across the continental shelf and all the way to an onshore refinery.
Every single piece of steel has to reference the exact same mathematical 0 point.
Wow. So if the offshore survey uses Vittoria's tidal logic and the onshore engineers use Imbituba's datum, the pipeline literally might not connect properly.
The engineering tolerances are just unforgiving. If a deep water wellhead is designed to sit at a specific depth based on an Imbituba referenced map, and map is offset by a meter because he used Vittoria predicted tides.
The robotic intervention tooling might crash into the seabed or fail to latch onto the well.
Exactly. It forces the contractor to apply incredibly complex tidal modeling to a survey happening far out of sight of land.
The mechanical precision demanded here is staggering.